Thank you.
Thank you very much, Louise, and welcome to all of our invited guests here today for this presentation. So this presentation is going to be in three parts. The very first part of this demonstration is when I will present a short presentation of 3 tips on how to develop good quality training data. And then we're going to hand over to Selçuk, who is going to talk in depth on his own personal experience on building good training data and some tips on what to watch out for in building good training data, with the ultimate aim of obviously building high quality production-ready machine translation engines. So first of all, the agenda today or the presentation today is in association with Transistent, and Selçuk is the founder of that particular company. Transistent is also one of our partners and is working with the Kantan platform on behalf of his clients in the Turkish market. So we're delighted to have Selçuk and his team as guest speakers today for this particular webinar. So I'm going to talk a little bit about what Kantan is, who we are and what we stand for, a little bit about the platform. I'm not going to dwell too long on that because I'm going to go straight into then what makes good training data. My presentation is about 10 minutes long, and then I'm going to pass over to Selçuk from Transistent.com, who will then talk in more detail about what makes good training data. And at the end of this, at the top of the hour, we'll have some time then for questions and answers. So please do send your questions to us via the chat interface, and we will endeavour to answer as many questions as we can before we run out of time today. So who is KantanMT.com? Well, we are a statistical machine translation platform. We are 100% based on the cloud. That means that we're very scalable, insanely inexpensive to operate, and it's a fusion of both statistical machine translation technology as well as translation memory technology. So we have actually fused those two technologies together, which means that our engines generally produce more accurate and more higher quality translations than most other engines in the market today. And because we're based on the cloud, it means that we have the economies that the cloud brings to the table, and we share this with our clients, which ensures that they get high speed, high quality translation services at a much reduced price. Now, the Kantan platform is vast. In fact, when we switched this platform on and started charging for it in March of last year, we had approximately 40 servers. Today, we have approximately 480 servers running this platform. So it's not only the fastest growing statistical MT platform, it's probably the biggest MT platform in the industry today. Now, our vision as a development team is to do 3 things really, really well, and these 3 things really count for our clients. And that's to give them the ability to customize their own engines, improve their own engines, and then deploy those engines at scale on the cloud. So everything we do today in our development team adheres to those 3 guiding principles. Will it help our clients customize their engines better, improve the engines faster, and deploy it at scale? Now, we've done a huge amount of work in the last 12 months. In fact, so far on the Kantan platform, there are 7,500 engines built, not by us, by our clients, our client base, the Kantan community worldwide. So far, they've uploaded 105 billion words of training data, which is a phenomenally large amount of data. And that's just counting the source words. It's not counting the target words. So if you were to include the target words in there, that would be about 200 billion words of training data. And so far, our clients, our members, have actually translated just over 1 billion words since the start of this year. So we're very proud and humbled to have such a great and active community, and they keep us honest and they keep us busy developing new features, which is fantastic. So who uses the platform? Well, there's a huge range of clients, and they range from the very, very small up to the very, very, very large, and it covers a huge range of industries, from the localization service provider industry to the car and automotive industry up to the high-tech large computer software companies. So our systems are used all over the globe today in up to 70 language combinations, translating content 24/7, 365 days of the year. And that's the reason, I guess, that we've been able to translate close to 1 billion words in the last few months. So the company is about 18 months old, and during that time frame we've introduced some key technologies that have really shaped the statistical machine translation industry today. In Q1 2013 we launched the first ever platform that was available on the cloud that you could simply log into and start building your own engine. So it's the first true multi-tenant machine translation platform. And it came with an integrated translation memory system called Total Recall. One of the biggest challenges our clients have is building engines fast and understanding or determining if those engines can produce high quality output. In Q2 2013, we developed an interactive building environment, just like an IDE, to help localization engineers build better MT systems. And that was the first time in the industry that highly visual tools and data analysis was used to enhance the training and customization process. In Q1 2014, we developed a technology aimed directly at project managers. One of the challenges project managers always faced in using statistical engines was to determine the quality of the translation output. Was it good, was it bad, or was it damn right awful? We developed Kantan Analytics to give a quality estimation score for every translation segment. So just like a fuzzy match score, we score each translation in the range of 0 to 100%. 100% meaning it's a perfect translation. And our clients are using that today, our project manager clients are using that today in order to predict the schedule, the cost, and the resources required to complete post-editing jobs. Because our clients operate at scale, and we have clients operating at ginormous scale, we also built a technology last year called Kantan Autoscale. And this enables our clients to deploy their engines over dozens and dozens of servers so that they can have high-speed, on-demand, instantaneous translation. And in fact, one of our clients today is using, on average, about 200 of our servers every single day to provide that service to their clients worldwide. So we are a relatively new company. Our journey has only just started, but we've covered a huge amount of ground over a relatively short period of time. So what makes good training data? Because fundamental to developing high quality engines is providing high quality training data. So there's three things to take into account when you're building or gathering training data together. Obviously the quality of the training data is of paramount importance. So if you introduce bad translation or badly translated data to a statistical engine, the engine will only be as good as that bad translated data. So obviously we have to have very high quality data in order to build high quality systems. Now we're lucky because most of our client base has been using translation and memory technology for many, many years. And generally speaking, they have managed those translation memories very carefully. They are corporate translation assets, and they generally are able to use them successfully in building engines. The second thing we have to look for is the relevance to the domain that we're translating. So every engine is trained and customized to specialize in translating for a particular domain, and that domain may be medical, legal, manufacturing, it could be IT, it could be e-commerce. So it's very important that when you're training an engine that you look at your training data to determine if it comes from that same domain. So for instance, it would be ill-advised to use medical training data in building an IT engine, because we won't get a high correlation between the way medical sentences are translated and the way IT sentences are translated. So it's very important that we match the training data to the domain of the engine, and that's the second factor to look for in choosing the correct training data. And then the third factor is the quantity. So generally speaking, the more training data you use, the better the capacity the engine has to mimic your translation styles and terminology. But that's not to say that you should throw bucket loads of training data into an engine. It's far better, believe it or not, to have less training data but of a higher quality than to have more training data of a lower quality. So this is a balancing act that our clients have to get right. Do they have lots of quantity and less quality, or do they have less quality, higher quality rather, and less quantity? So this is a balancing act that every client has to get right. And we work with our clients to get this mixture of quality versus quantity just right to build the highest possible engines. And in fact, the technology called Kantan Build Analytics helps our client go through this process to make sure that they get this equation correct. Now, there are 4 types of training data that you can consider when you're building an engine. And the first type of training data is something that our clients generally have an abundance of. It's bilingual translation memory files. Generally, they're TMX files, but they can be XLIF files, or they could be simple text files. No matter which format you choose, it is the fundamental training resource needed to build a high quality statistical engine. So lots of our clients will upload their client translation memories and use that as a base to build a high quality engine. The second type of training data is monolingual data, and this is always in the target language. And we've made it really easy for our clients to introduce monolingual data to their Kantan engines because we accept docx files, PDF files, text files, or in fact, you can use the Kantan Spider technology to spider websites and aggregate and collate your monolingual data for you. The third type of training data, which has a positive impact on the quality of an engine, is glossary or term databases. These are typically TBX files exported from products like Multiterm or perhaps the Memo Q Term Manager. But they need not be. A lot of our clients, believe it or not, simply upload a spreadsheet, and column A contains the source text, column B contains the translation for that source text. So again, we've made it very easy for our clients to introduce terminology lists to the training process. And then the fourth type of training data is stock engines. So if you don't have enough data yourself to build an engine for one of your clients, you can actually use our stock data, which is about 5 billion words. It's in over 200 language combinations. You can use that data to augment your client data and achieve a high quality engine for your client. So what makes good training data? It's 3 factors. It's quality, the relevance of the training data, and obviously the quantity. And that's the order in which you should look at your training data. Is it of high quality? Is it of high relevance to the domain I'm training for? And do I have sufficient quantity of that data to make an engine? So that's my 3 things to watch out for in building high quality engines, or building good training data that will result in building high quality engines. Now at this juncture, I want to hand you over to a real expert in this field, Selçuk, who is the founder of Transistent, and that is a leading LSP and technology provider and an expert in building high quality MT systems. And he's going to share some of his insights into how he does this for his clients today. So I'm going to switch over now to Selçuk, and he's going to take over this presentation. Thank you very much for your time, and I'll answer any questions at the end of this presentation later on.
Thank you, Tony, for this great introduction, and thanks for providing this opportunity to exchange some ideas and experiences on training data issue for SMT systems. So let me write on this. Yes. I'm Selçuk Özcan, co-founder of Transistent. Let me first of all introduce my company. We are a very young company, but we have talented and competent staff in this machine translation technology field. We are based in Istanbul. You can see the several services that we offer, MT services, including raw output, custom engine services, and post-editing. And additionally, we offer quality automation services, training consultancy, and traditional translation as well. Here you can see our memberships and our partners. KantanMT is one of our partners in terms of machine translation platform. So today I would like to provide a wide perspective on training data issue, and I would like to first of all give an information about SMT systems in general, and compare the effect of training data with the engine's overall performance. So let's have a look at the basic components of statistical machine translation systems. As Tony also mentioned, these are well-known information about SMT systems. We have monolingual data, bilingual data, glossaries, and some rules and tasks. And we in general call monolingual data and bilingual data as the general training data. And training data is the core component of the system. So how we utilize those components, we create a language model using the monolingual data, and by utilizing bilingual data, we create the translation model. So you can consider the bilingual data as the translation memories, or previously translated text with the source and target itself, and monolingual data can be considered as, again, previously translated text, but just the target segments, but it can be also technically written in the target language itself, but the most important thing is the relevance with the domain you're intended to build your engine for. So how we utilize and how the system goes on. By the way, this is a technical issue and technical concept in general, but I would like to avoid the most technical aspects and issues. I would like to give you a basic approach and perspective on it. So one of the most important procedures and processes, pattern formation and mapping, and how we do that. With bilingual data, you can see the source segment and target segments. We separate them from each other, and we align them with each other. Some technical procedures are required as well, tokenization and post-tagging and etc. And by this way, we create the translation model basically. And for the language model, we take the target segments of the previously mentioned bilingual data, and we have some additional monolingual data to create the language model with the similar system as translation model. So you can see how those data and models are utilized in the system. In general, I mean, you have the source text and the target. You will receive the target text from the MT systems, and you can see the components of the system and how does it work in general. So it's not much important to emphasize all of the technical aspects of machine translation building and optimization and customization procedures. Here today we're intending to emphasize on the training data session. So you can see the pre-processing rules and post-processing rules here. It's not possible to include all of the tasks, but just to give you a perspective on it, I have included some of them. The pre-processing rules can be implemented for the source text to be translated and for the training data as well, just to be sure that our training data will work well to build a high quality MT engine. Post-processing rules are for the target text. I mean, the system implements those rules before giving out the target text. So many of them are also, I mean, the pre-processing rules are related with the training data as well. So we should, I think you may want to have a deep knowledge on the tasks related to optimization as well, since every task and procedure is related to the training data. Training, as I said before, training data is the core component of the system. So how we handle is that we have data analysts, and the tasks related to data analysis are data crawling, as Tony also mentioned. Spidering is a tool that we use, and we have lots of tools that we crawl data on the open source tools. And this can be a monolingual or bilingual data as well. And gathering and normalizing the data is a must before creating your engine, your translation model or language model. And building corpus is another task that data analysts perform. And corpus analytics gives this procedure gives us much details on the training data, and we can include new data, modify the existing data, some parts of it. I mean, we have lots of info about the pattern formation that's intended to be created for the translation model. So on the other end, we have the testing team as well. But testing team, the procedures that testing team handles are a little bit related to the quality improvement procedure of the engine, intended engine. So before going out the task that this team handles, let's see the system's behavior. I mean, how can it be possible for team to improve the output quality of engine? I mean, the engine's life cycle in general. Here you can see a diagram. Basically describes how the systems behave before obtaining a mature production system. You can see the incremental improvement axis and the quality level axis. The main objective is to obtain a mature production systems for a specific language pair and for a specific domain in terms of fields of expertise. So it will be much technical details if I try to describe and explain each of the details, but it's important to know that this is not a goal, obtaining a high quality engine. It's a long lasting journey. It's not a final destination. It's a really hard journey to obtain mature production systems, and there are lots of tasks and procedures that are required to be performed before obtaining mature production systems. So let's go back to the testing team's procedures and how we handle those procedures, how the team handles the procedures, and what are them. Gap analysis is one of the fundamental procedures, and by the way, KantanMT platform also provide and offer this service for us as well, and it may be possible to detect the gaps in your corpus or pattern formation using some third-party tools as well. But thanks to KantanMT platform, we do not need to utilize any other third-party tool for that. And the quality evaluation and test reports, and this procedure is a very significant procedure for evaluating the output quality and being aware the actual position that we are on, and what would be the distance and how would we reach out to mature production systems. And output and corpus analytics. And this procedure, this item is a combined one with those two above. And all of them are related with the training data. By testing the outputs of the MT engines, we typically get aware that the differences between the error typologies, and we define and decide how to fix some errors in which way. Some of the errors are required to be fixed, including some training data, and some of them are possibly due to be fixed using some rules and special tasks, some post-processing, post-editing task, or pre-processing, or whatever it is. So the last item is, as I mentioned before, including new data and rules. And for these tasks, our testing team works closely with the data analysts. As I said before, it's very much related with the training data. So for the last item, you can see some procedures that we perform before the first two training steps, just to define and create the improvement plan, a realistic and objective improvement plan, and the way that we are going to take, the pace that we're going to take. And on the right side, you can see the procedures that we perform to reach out to mature production systems. It's much more related with the testing team's performances. So you can see that we have bilingual corpus analytics, lemmatization, missing inflections, and word and lemma distribution map. This is a very much significant procedure for companies or for the teams that are working on a very different language pairs. I mean, the language pairs that have different, totally different linguistic structures, such as English and Turkish and German and Turkish. So as Tony introduced me, we are mainly working on Turkish language. So we have lots of required procedures to perform the process before including the training data for engine creation. So bilingual corpus analytics, as I mentioned, those are the procedures, and monolingual corpus analytics are comparing the bilingual data with monolingual data, just to be sure that the two sets of data are really related with each other and coherent. That's much important since translation model gives us lots of candidate translations outputs, but the system compare and renders the outputs just according to your language model, and the language model is based on the monolingual data that you include or utilize. So this is also a significant performance for us, and defining the most appropriate language model configuration is a different aspect of the corpus analytics item. So for the last term extraction part, and extracting the candidate terms and separating the terms and the lexical units as well. So this item is a very, I think, quite complicated performance, since it's much important to separate those units. I mean, which ones should be included in your dictionary, which one should be included your terminology list, and this terminology management issues, I mean the traditional terminology management issues are also due to be utilized for a healthy performance. So on the other hand, the terms that are that should be included in the training data, and the terms that are used to be, I mean that should be included in the runtime specific glossaries should be different as well. So some specific glossaries and dictionaries should be created. And I don't want to give much details on the procedures on the right side. Please feel free to contact me if you want to learn more about that and how we handle the procedures. So we are very closing to the conclusion, and I do not want to take your time much, and it's a very complicated issue. If we want to include all of the issues, it would take much time, longer time. So this can be considered as a general suggestion. Ensure that your training data is clean and normalized, and is relevant to the related domain, and has a complete and healthy linguistic pattern form, and error proof that it should. This means that your training data should contain no linguistic errors and linguistic patterns, and clean and normalization procedures regarding to basically some tags and formation and formattings, and also ensure that your training data consists of coherent monolingual data and bilingual data, as I previously described on a few slides before. So for the last, KantanMT's rejected segments feature can give you the segments that are too long to be a meaningful parsing for the system, and some mismatched text and placeholders, a source and target misalignment, and bad formattings also are included in the report, and incorrect language combinations are included also in the report. So thanks to KantanMT platform, we do not have to utilize some other third-party tools to perform those procedures and progresses, and we utilize this feature as well. So it can be a suggestion for you as well, just to use KantanMT's rejected segments feature to be sure that, I mean, partially it's not much logical to believe that this feature will inform you all of the unhealthy segments, and I mean segments should be fixed, but partially this will make you avoid segments that have some errors. So this will make you have a high quality translation model or language model in terms of machine translation systems. So thank you very much for providing this opportunity to exchange some ideas and experiences. I think if you have, we will handle the question and answer part here. If you have some questions, I will be glad to answer them. Thank you very much. Let me make the Tony a presenter. Yes. Tony, can you hear me?
I can indeed. Thank you very much, Selçuk, for that insightful presentation and for your conclusions and what to look for in picking high quality, suitable and relevant training data. I'm going to hand back now to Louise because we have quite a number of questions that have been posted to us. So we're going to go through these questions and hopefully we'll be able to provide helpful and useful and practical answers to each one of those. So I'll pass you back to Louise now. Thank you very much, Selçuk.
Tony, thank you very much.
No problem, it's my pleasure.
Thank you very much for a very good presentation. I'm sure our listeners got lots of tips on how to prepare training data, and we've had quite a few questions come in. So if you just bear with me, I'm going to read a few off here. The first one is, what kind of additional monolingual data that was mentioned in the presentation do you have and use? So I'd actually like both of you maybe to just give a quick short answer to that.
Selçuk, do you want to go first?
Yeah, no, you may take the first.
Okay.
No problem.
As part of our stock engines, if you're on the KantanMT platform, as part of our stock engines, all stock engines include monolingual data within the domain that each stock engine is designed for. So for instance, if we have a medical stock engine, we also have monolingual data from that domain. If it's a financial stock engine, we have financial data in that target language, in that monolingual format as well. Now, in addition to that, most of our clients always upload their own monolingual data. And to get that data, they can upload PDF files straight into their engine, or they can upload docx files or simple text files. And we will normalize that data, we will cleanse that data, and we will get it into a suitable format for machine learning. And that's an automatic process. And then the final step is that if clients want to use the Kantan Spider service, they can give us a list of URLs, these are just basically websites, and we will spider those sites for them and collate that monolingual data. So for instance, we recently built an engine, a medical engine for a client in the US. It was a Mexican Spanish engine, and we actually spidered some of the government health service sites to grab a very large dictionary of monolingual data describing over 150,000 medical terms. And that was a great boost to the quality of the engine, but more importantly, the fluency of the engine as well. So that's the three areas which we can help in delivering suitable and relevant and quality monolingual data. Selçuk, do you want to add anything to that?
Yes, I can have some short sentences and answers on that, and I can tell you how we handle this procedure. It's a very similar one. We crawl the open source open source projects and the open source data, and we gather. I mean, first of all, we define some required filters just to ensure that we have the relevant monolingual data from the open source tools. Just spider technique is one of them, and finally we create a total corpus on the with the monolingual data that we acquire and gather each other. And for the last, we render and filter out the irrelevant one, and we have some fine filtering for that, just to assure that we have the relevant monolingual data only.
Brilliant, thank you. That's a good answer from both of you. The next question up here is, in your experience, could you define how many words would be considered too many in a long segment? Sorry. Selçuk, do you want to have a crack at this one again?
Yes, it can be. It will probably give you an insider approach on it when you're used to working on that. And if you try to parse the segments and have the tagged elements of the morphemes and etc., then you will probably have known that this will be a pretty long sentence and segment to be parsed and utilized into the translation model. And I don't know, maybe Tony has a more technical question for that, answer for that.
Yeah, as part of data cleansing, any data that's uploaded to a Kantan engine goes through 12 phases of data cleansing. And it's only the training segments that get through those 12 phases are actually included in your engine. Now that might seem a very harsh regime to have, but it's been put in place for a very good reason. Again, remember the three things to look for in training data is quality, relevance, and quantity. So we make sure that all of the data you upload is very, very clean from a structural point of view, from a linguistic point of view, before we include it in your engine. So those 12 phases of data cleansing is very, very important. And if it fails any of those 12 steps, the data is rejected. Now, one of those steps is a check for long segments. So in the Kantan environment, by default, any segments that have more than 40 words are excluded for the purposes of training. Now, that's the default value. That can be changed by our clients depending on the language combination, but the default is 40 words, okay, or 40 tokens actually. So that's what we consider too long for the purposes of statistical training. Okay.
Okay, thank you. I
have one thing to add.
Sorry, go ahead, Selçuk.
On that. Yes, the tuning procedure and the testing procedure can be utilized for that as well, just to compare the results. And if I have those long segments into the translation model, or if I split them and compare the results and create a threshold, as Tony mentioned, 40 or 45 and 50, whatever it is, it depends on the language pairs.
Okay, so I'm just going to read out this one here. Thank you for the great presentation. As someone who is trying to understand the right utility and features of MT, and being aware that quantity does not make a quality engine, I still find it hard to figure out how many weeks, months, years of work, or dozens, hundreds, thousands of input a proper or functioning engine would require. Out of your experience, is there a figure in mind? Even if, as stated, quantity does not entirely represent quality. I know that was a long one, but Tony, would you like to kick off on that?
Okay, there's quite a number of questions in there, but I'll answer this in relation to, I'll give a statistical answer based on the entire community of Kantan users today. We have 7,500 engines on our system. Okay, now those engines range from very small engines all the way up to very, very large engines. So the biggest engines, which would be the engines working on e-commerce sites, contain about 1 billion words each. Okay, so if I exclude those very, very large engines because they do distort the average engine size because they are so enormous, if I take those billion-word engines out of the problem domain, the average size of a Kantan engine today is approximately 5 million source words. Okay, so that's the average size. So if you look at some of the largest clients, say in the automotive industry, they would have engines in and around 5 million source words, which would be producing very high quality output. Now, the follow-on question of that is, how long does it take to build an engine of that size? And I guess, how long would it take to accumulate that many words? So the first question is, how long would it take to build an engine like that? Well, on the Kantan platform, we build an engine at approximately 4 million words per hour. So a 5 million word engine would take from an hour to an hour and a half, maybe 90 minutes most to build, and that's insanely fast. And we can do that because we have so many servers. We have 480 servers running the system. Now, because that build time is so fast, it means that our clients can retrain their engine more frequently, and they can retrain more engines. And that means they can have higher levels of productivity and higher levels of quality output than most other systems. Okay, so that's the first question. The second one then is, how long would it take to get that many words? Well, most of our clients would be able to deliver those words themselves. But for the clients that don't have 5 million source words, what they normally do is they upload what they have, and then they select one of our stock engines to help them achieve that type of word count. Okay. Now, when we look at an engine for a client, we obviously look at the number of source words, but the key number for us is the number of unique words in an engine. So for instance, if I want to have a high quality German engine in a narrow domain, it might consist of 5 million source words, but more importantly, the unique word count in that engine is going to be close to 1 million or slightly more than 1 million unique words. And if I do that when I'm developing that engine, I know that that engine is going to know a lot about speaking German and translating into German. So we don't just look at one word count, we look at a number of different word counts to achieve a high-end quality engine. Now there is one other factor that we have to consider as well. If you've got a language that has high level of inflected forms in that language, that generally is an indicator that you're going to need a lot more words, because we need more examples and usages of those inflected forms in order to educate the system or train the system. So generally speaking, highly inflected languages need a lot more training data. So if you're building an engine, for instance, for Hungarian, which is an incredibly inflected language, you generally need in excess of 2 to 3 times that word count before you get a workable, high-quality system. So I know that's not a short answer, but it wasn't a short question, I guess. But hopefully that has given you an insight into the kind of numerics and the size that's required to build an engine. Selçuk, would you like to comment on that in terms of maybe Turkish and how that
Well, thank you.
language as well?
You have provided all of the required aspects of the issue.
Okay, thank you very much. Do we have time for another question?
So actually, yeah, we just have time. We're going to wrap up it. This is a shorter webinar than the usual one, so we're just going to have time for just maybe 1 or 2 more questions. I just have one here. This is just for Selçuk. How long does it usually take to normalize the data? And have you noticed any differences in the time it takes per language pair?
I did not understand well the second one. I cannot hear you well, by the
Oh,
way.
my
First
apologies.
one is okay?
Yeah, sorry about that. So the first part of the question is, how long does it take for you to normalize your data? And then,
Uh-huh.
have you noticed any differences in the length of time it takes across different language pairs?
Uh, Normalizing data is, I mean, the time frame for that depends on the language pair that you're working on and the mm, how clean are your data. I mean, the cleanness and what's the source of the data that you have gathered and obtained, and what's in fields of expertise. Do you have it? If you have lots of formulas or suspicious characters in the data, it would probably take longer to normalize your data. And if you cannot trust your source that you gathered the data, and it will probably take longer on that. So it depends on the data as the factors that are provided you. And on the other hand, for the second one, I think it's more about the linguistic structure, the difference between the linguistic structures. If I am correct, Louise?
Mm-hmm. And have you noticed any language pairs taking longer? For example, with the Turkish language, how long would that on average take?
Take two?
Yeah, an example with perhaps the Turkish language of how long it might take to normalize the data, just in your experience.
If it's for the initial training and for the second one, it will probably take averagely 10 days or 12 days. It also depends on the number of the team members that you have, and it will probably take at least 10 or 15 days to normalize the data. And I mean, if for average 10 million words or something like that, and it depends on the volume of the data as well.
Yeah, I'd just like to comment on that question as well, because it really is a very good question. It's almost like how long is a piece of string, and because it is very much data. The answer is, or the time to normalize data is very much data driven. But we do have a kind of a rule of thumb in the Kantan professional services team, and it goes as follows. If you've got standard text that consists mostly of words, okay, so this is text that comes in a bound volume like a book, or maybe it's online help text, or perhaps it's user interface text. So the predominant token is a word. That tends to be normalized very quick because you don't have mixed tokens in your data set. You generally just have words, okay? Now, if you have lots of numerical data, scientific formulas, perhaps product specifications, maybe measurements and weights, maybe a lot of part numbers. So you've got a high diversity of tokens, okay, individual tokens, as opposed to just simple words. That type of data tends to take a little bit longer to normalize. And the reason for that is that you have to instruct your engine, which you can do using the Gentry programming language and named entity recognition software that's built into the Kantan platform. You have to educate the engine to recognize those tokens correctly, because if the engine doesn't know about that data, it can't really handle it during the translation phase. So the more diverse the tokens in your input, the longer the normalization process is. The less diverse the tokens are, the quicker that process is. And if it's just simple words, it's generally automatic. It's just the system handles that automatically for you. So that's kind of the rule of thumb that we use. And we use that rule of thumb, by the way, when we're working with clients to schedule how we will construct and build their engines, because we have to give them some sense of the schedule around building the actual engine. So that's the rule of thumb we use. So hopefully that'll give you an insight to how we go about estimating that effort.
Brilliant. Thank you very much, Tony, and thank you very much, Selçuk. Now, unfortunately, we have reached the end of the allocated time for this webinar. We do still have more questions, but what I will do afterwards to send you an email with the answers from Selçuk and Tony. And I will also send you a copy of the recording and a link to the presentation slides on SlideShare. And you can come back to us if you have any more questions in the future. Okay, well, I'd like to say a big thank you again to Tony and Selçuk for taking the time to present this webinar today, 5 tips for preparing training data for machine translation. Thank you very much, and we look forward to seeing you at future webinars.
Okay, thank you. Thank you.
Yes.